Have you ever gazed up at the night sky and wondered what lies beyond our galaxy? Imagine for a moment that the Milky Way, along with billions of other galaxies, is being pulled toward a mysterious point in the universe. This isn't just a figment of science fiction, it's a gravitational anomaly known as the Great Attractor. The Great Attractor is a region in space that exerts an immense gravitational pull, drawing in galaxies from all directions. It's located in the direction of the Centaurus and Hydra constellations, about 150 to 250 million light-years away from us. What makes it so fascinating is that it's hidden behind the zone of avoidance, a part of the sky obscured by our own Milky Way's dense dust and gas. This means that, despite its powerful influence, we can barely see it. The discovery of the Great Attractor dates back to the late 1970s, when astronomers noticed that galaxies were moving toward a specific point in the sky. This peculiar motion was puzzling. Why were these galaxies accelerating toward this unseen force? It wasn't until the early 1980s that researchers began to piece together the puzzle, realizing that the gravitational pull was coming from a massive concentration of matter, likely a supercluster of galaxies. But here's where it gets even more intriguing. The Great Attractor is not just a single entity. It's part of a larger structure known as the Laniakea supercluster, which encompasses our Milky Way and thousands of other galaxies. This supercluster is a vast network of galaxies bound together by gravity, and the Great Attractor is at its core. It's a reminder of how interconnected the universe is, with each galaxy playing a role in this cosmic dance. Despite its significance, the Great Attractor remains elusive. The challenge lies in the fact that we can't directly observe it. The dense clouds of gas and dust in our own galaxy obscure our view, making it difficult to study the region in detail. Astronomers have had to rely on indirect methods, such as measuring the motion of galaxies and mapping their distribution, to infer the presence of this gravitational anomaly. So, what does the Great Attractor mean for the future of our universe? As galaxies continue to be drawn towards it, we're witnessing a cosmic tug-of-war. This gravitational pull could influence the fate of our galaxy and others, potentially leading to collisions and mergers over billions of years. It raises profound questions about the structure of the universe and the forces that shape it. In a way, the Great Attractor serves as a metaphor for the mysteries of the cosmos. It reminds us that there's so much we still don't understand about the universe. As we continue to explore and uncover its secrets, we may find that the answers to our questions lie in the very forces that bind us together. The Great Attractor is not just a point in space. It's a gateway to understanding the vast, intricate web of the universe and our place within it.
In the 1970s, something remarkable happened in the field of astronomy. As astronomers turned their telescopes toward the vast expanse of the universe, they began to notice a peculiar phenomenon. You see, according to Hubble's law, galaxies should be drifting apart, expanding away from each other like dots on a balloon as it inflates. But what they found was puzzling. Many galaxies were not just moving away, they were actually being drawn toward a specific region of the sky. This unexpected motion was termed peculiar velocity. It was as if these galaxies were caught in a cosmic dance, pulled by an unseen force. Imagine standing in a crowded room where everyone is supposed to be moving away from each other, but instead, a few people are inexplicably gravitating toward a corner. That's what astronomers were witnessing on a grand scale. The implications were staggering. If galaxies were moving toward this mysterious region, it suggested the presence of something massive lurking in the shadows of the universe. But what could it be? This invisible entity was not just a figment of imagination, it was a gravitational force strong enough to influence the motion of entire galaxies. Researchers began to speculate about its nature, and thus the term Great Attractor was born. The Great Attractor is located in the direction of the Centaurus constellation, roughly 150 to 250 million light-years away from us. It's a region that's shrouded in mystery, hidden behind the Milky Way's dense clouds of gas and dust. This makes it incredibly challenging to study. But scientists believe that the Great Attractor is part of a massive supercluster of galaxies known as the Laniakea supercluster, which includes our own Milky Way. What's fascinating is that the Great Attractor isn't just a single object. It's likely a conglomeration of galaxies, dark matter, and other cosmic structures. Dark matter, which makes up about 27% of the universe, is invisible and doesn't emit light, making it incredibly difficult to detect. Yet its gravitational influence is undeniable. It's like a ghostly puppeteer, pulling the strings of galaxies without revealing its true form. As researchers delved deeper into the mysteries of the Great Attractor, they began to realize that it's not just a local phenomenon. It's part of a larger cosmic web, a network of filaments and voids that make up the structure of the universe. This web connects galaxies across vast distances, creating a tapestry of cosmic relationships that we are only beginning to understand. The Great Attractor challenges our perception of the universe. It reminds us that there's so much we don't know, that the cosmos is full of surprises waiting to be uncovered. Each discovery leads to more questions, pushing the boundaries of our knowledge. The pursuit of understanding the Great Attractor is a testament to human curiosity and our relentless quest to explore the unknown. So, as we gaze into the night sky, we're not just looking at stars and galaxies, we're peering into a complex, dynamic universe filled with unseen forces and hidden wonders. The Great Attractor is a reminder that there's always more to discover, and that the universe, in all its vastness, holds secrets that challenge our understanding of reality itself.
The Great Attractor is one of the most fascinating mysteries in our universe, yet it remains frustratingly elusive. Imagine standing on a beach, staring out at the ocean, only to find that a thick fog rolls in, obscuring your view of the horizon. That's what astronomers face when they try to observe the Great Attractor. It's hidden behind a dense curtain of gas, dust, and billions of stars that make up our own Milky Way galaxy. This region of space, known as the zone of avoidance, is like a cosmic blind spot. It's a vast area where our line of sight is blocked, making it incredibly challenging to study what lies beyond. The Milky Way is not just a beautiful band of stars, it's a massive collection of matter that interferes with our observations. The dust and gas absorb and scatter light, making it nearly impossible to see the objects behind them using traditional optical telescopes. To tackle this problem, astronomers have turned to innovative techniques that allow them to peek through this cosmic veil. One of the most effective methods is infrared astronomy. Infrared light can penetrate dust clouds much better than visible light, revealing hidden stars and galaxies. It's like using night vision goggles in a dark room. You can see what's there, even if it's obscured by shadows. Then there are X-ray observations. The Great Attractor is thought to be a region of intense gravitational pull, which means it likely contains a lot of hot gas emitting X-rays. By using space-based telescopes that can detect these high-energy emissions, scientists can gather information about the structure and dynamics of this mysterious region. It's a bit like listening for the roar of a distant waterfall when you can't see it. The sound gives you clues about its presence. Radio telescopes also play a crucial role in this cosmic detective work. They can pick up radio waves emitted by hydrogen gas, which is abundant in the universe. By mapping these signals, astronomers can create a clearer picture of the distribution of matter in the zone of avoidance. It's akin to using sonar to navigate through murky waters. You may not see the obstacles, but you can sense their presence. Despite these advanced techniques, mapping the universe remains a daunting task. A significant portion of it is hidden from our view, creating gaps in our understanding of cosmic structures. It's like trying to chart a mountain range. While a brilliant sunset casts everything in shadow, you know there's beauty and complexity beyond that horizon, but the light obscures the details. The Great Attractor, with its gravitational pull drawing galaxies towards it, is a reminder of the vastness and intricacy of our universe. Each new observation, each breakthrough in technology, brings us a step closer to uncovering its secrets. The challenge lies not just in what we can see, but in what we can infer from the shadows. As we continue to push the boundaries of our observational capabilities, who knows what wonders await us just beyond the veil? In 2014, a remarkable breakthrough reshaped our understanding of the universe. Scientists unveiled the Laniakea supercluster, a colossal structure that houses our very own Milky Way galaxy. Picture this. Spanning an astonishing 520 million light-years, Laniakea is not just a collection of stars. It's a vast cosmic neighborhood containing over 100,000 galaxies. Each of these galaxies is like a tiny island in an immense ocean of space. At the heart of this supercluster lies the Great Attractor, a gravitational powerhouse that influences the motion of galaxies across this sprawling expanse. Imagine the Great Attractor as a massive whirlpool in a cosmic river system, drawing galaxies toward it like water droplets flowing toward a basin. It's a captivating image, isn't it? The Great Attractor organizes the flow of galaxies, creating a gravitational dance that we are only beginning to comprehend. As we explore Laniakea, we realize that our Milky Way is just one small part of a much larger tapestry. The sheer scale of this supercluster is mind-boggling. To put it into perspective, if you could travel at the speed of light, it would take you 520 million years to cross from one end of Laniakea to the other. That's longer than the entire history of human civilization. What's even more fascinating is the way galaxies within Laniakea interact with one another. They're not just drifting aimlessly. They're part of a complex web of gravitational forces. Some galaxies are moving toward the Great Attractor, while others are being pulled in different directions. This cosmic choreography is a testament to the dynamic nature of our universe. And yet, despite the vastness of Laniakea, much of it remains shrouded in mystery. There are regions we cannot fully observe, hidden from our view by cosmic dust and the limits of our technology. It's a humbling reminder of how much we still have to learn about the universe we inhabit. As we delve deeper into the study of Laniakea, we uncover clues about the formation and evolution of galaxies. Each galaxy tells a story, a history etched in the stars. By studying their movements and interactions, we gain insights into the fundamental forces that shape our universe. Laniakea is more than just a supercluster. It's our cosmic home, a reminder of our place in the grand scheme of things. It challenges us to look beyond our own galaxy and consider the vastness that surrounds us. In this intricate cosmic web, we are all connected, part of a larger narrative that stretches across time and space. So, as we gaze up at the night sky, let's remember that each twinkling star is part of a galaxy, and each galaxy is part of Laniakea. Together, they form a magnificent structure that not only defines our cosmic neighborhood, but also invites us to explore the mysteries of the universe. The journey of discovery is far from over, and who knows what wonders await us as we continue to unravel the secrets of Laniakea and beyond. The Great Attractor is one of the most intriguing mysteries in our universe, a gravitational anomaly that pulls galaxies, including our own Milky Way, toward it. But what exactly could this enigmatic force be? Let's dive into some of the leading theories. First up, we have the possibility of a massive galaxy cluster, specifically the Norma cluster. Discovered in the region of the Great Attractor, this cluster is home to thousands of galaxies. Just imagine the sheer scale of it. With such a vast collection of stars and cosmic material, it exerts an enormous gravitational pull. This could explain why galaxies are moving toward this area. The Norma cluster could very well be a significant contributor to the Great Attractor's influence. Then there's the intriguing concept of dark matter. This mysterious substance makes up about 27% of the universe, yet it remains invisible and undetectable by traditional means. We can only observe its presence through its gravitational effects. In the vicinity of the Great Attractor, dark matter may form a concentrated halo, amplifying the gravitational pull we experience. This halo could be a key player in the cosmic dance of galaxies, shaping their trajectories and movements. But wait, there's more. Beyond the Great Attractor lies the Shapley Supercluster, an even larger collection of galaxies. This supercluster is massive, containing thousands of galaxies and exerting an immense gravitational force. It's possible that the Shapley supercluster is influencing the motion we observe, dominating the gravitational landscape of our local universe. The sheer scale of these structures raises fascinating questions about how they interact and shape the cosmos. Each of these theories opens up a Pandora's box of questions. If the Great Attractor is primarily driven by the Norma cluster, what does that mean for our understanding of galaxy formation and evolution? If dark matter plays a significant role, how does that reshape our theories about the universe's composition? And if the Shapley supercluster is the main player, what does that say about the large-scale structure of the universe itself? As we continue to explore these possibilities, we're not just piecing together the puzzle of the Great Attractor. We're also gaining insights into the fundamental architecture of the cosmos. The more we learn, the more we realize how interconnected everything is, from the tiniest particles to the largest galaxy clusters. The universe is a grand tapestry, and the Great Attractor is just one thread in this intricate design. So, as we gaze into the night sky, let's remember that there's so much more happening beyond what meets the eye. The Great Attractor is a reminder of the vastness of our universe and the mysteries that still await discovery. Each theory, each observation, brings us one step closer to unraveling the secrets of the cosmos.
The existence of the Great Attractor fundamentally reshapes our understanding of cosmic flows. It's a reminder that the universe is not just expanding uniformly, it's a complex web of matter, energy, and hidden forces that we are only beginning to grasp. Imagine this: our Milky Way galaxy is not drifting aimlessly through space. Instead, it's part of a vast migration, drawn toward a gravitational well that we can't fully comprehend. This great attractor, located in the direction of the Centaurus and Hydra constellations, is a massive concentration of galaxies and dark matter. It's like a cosmic magnet, pulling everything in its vicinity closer. As we move through the universe, we're not just floating along, we're on a journey, a cosmic dance influenced by the gravitational forces of this unseen giant. What does this mean for us? For one, it challenges the notion that the universe is a simple, isolated expanse. Instead, it's a dynamic, interconnected system where galaxies interact in ways that can alter their paths. The Milky Way, along with our neighboring Andromeda, is being pulled toward this great attractor, and in billions of years, this gravitational pull will carry us into new regions of the cosmos. Picture the night sky changing over eons. Stars that once seemed fixed in their constellations will shift, new galaxies will come into view, and the familiar patterns we've known will evolve. This migration is not just a physical journey, it's a profound transformation of our cosmic perspective. As we approach this gravitational well, we'll encounter regions of space that are currently beyond our reach and understanding. What mysteries lie in those distant realms? What new phenomena will we discover? The implications are staggering. It's a reminder that our place in the universe is not static. We are part of a grand narrative, a story that unfolds over billions of years. The Great Attractor also highlights the role of dark matter and energy in shaping the cosmos. These elusive components make up a significant portion of the universe, yet we know so little about them. Their influence is felt in the way galaxies move and cluster, and understanding them could unlock secrets about the universe's fate. So, as we gaze up at the stars tonight, let's remember that we are not just observers. We are participants in a cosmic journey, drawn toward the Great Attractor, moving through a universe rich with complexity and wonder. The night sky will change, and so will our understanding of our place within it. Embracing this journey means embracing the unknown, and that's where the true adventure lies.
The Great Attractor is one of the most intriguing enigmas in modern astronomy. Imagine a colossal gravitational force lurking in the depths of space, pulling galaxies, including our own Milky Way, toward it. But what exactly is this mysterious entity? Is it a massive cluster of galaxies, a concentration of dark matter, or something even more complex? To understand the Great Attractor, we first need to grasp its scale. It lies about 150 to 250 million light-years away from us, in the direction of the Centaurus constellation. This region of space is home to a vast collection of galaxies, and it's believed that the Great Attractor is a gravitational focal point for these galaxies. But here's where it gets interesting. We can't see it directly. The Great Attractor is hidden behind the zone of avoidance, a region of the sky obscured by the Milky Way's own stars and dust. This makes it incredibly challenging to study. Now, some scientists propose that the Great Attractor is a massive cluster of galaxies, possibly the Norma cluster, which is one of the largest clusters in that region. Others suggest that it could be a concentration of dark matter, an invisible substance that makes up a significant portion of the universe's mass. Dark matter doesn't emit, absorb, or reflect light, making it elusive and difficult to detect. If the Great Attractor is indeed a concentration of dark matter, it could reshape our understanding of cosmic structures and the forces that govern them. But what if the Great Attractor is just a stepping stone? Some astronomers speculate that it might be part of a larger structure, like the Shapley supercluster, which is even more massive and lies beyond the Great Attractor. This supercluster is a gravitational titan, influencing the motion of galaxies over vast distances. If the Great Attractor is merely a component of this larger framework, it raises fascinating questions about the interconnectedness of cosmic structures. As we ponder these mysteries, one thing is clear. We are not standing still. The Milky Way, along with our neighboring galaxies, is moving toward this hidden destination. We are racing through the cosmos at an astonishing speed of about 600 kilometers per second, drawn inexorably toward the Great Attractor. This movement is a reminder of the dynamic nature of our universe, where nothing is static and everything is in flux. In seeking to unlock the secrets of the Great Attractor, we may uncover deeper truths about the nature of the universe itself. What is the origin of this gravitational force? How does it fit into the grand tapestry of cosmic evolution? And ultimately, what does it mean for the fate of the universe? As we continue to explore and gather data, we inch closer to answering these profound questions. The Great Attractor remains a tantalizing mystery, a cosmic puzzle that challenges our understanding of space and time. Each discovery we make brings us one step closer to unraveling the complexities of the universe, revealing the intricate dance of galaxies and the forces that bind them. In this quest for knowledge, we are not just observers, we are participants in a grand cosmic journey, one that invites us to explore the unknown and embrace the wonders that lie beyond. The Great Attractor is one of the universe's most intriguing mysteries, hidden away in a region astronomers call the zone of avoidance. This area is notoriously difficult to study because it's obscured by the dense dust and gas of our own Milky Way galaxy. But thanks to advanced technology, we're beginning to peel back the layers of this cosmic enigma. To tackle this challenge, scientists employ a variety of telescopes that allow us to observe the universe in ways our eyes simply cannot. Take X-ray telescopes, for instance. Instruments like ROSAT and Chandra are designed to detect the hot plasma that fills massive galaxy clusters. Even when galaxies themselves are obscured, the surrounding gas emits X-rays, creating a bright glow that marks their positions. This is crucial because it helps us identify where these hidden galaxies are located, even if we can't see them directly. Then there are infrared surveys, such as IRAS and 2MASS. Infrared light has a unique ability to penetrate the dust that clouds our view of the cosmos. While visible light struggles to pass through, infrared waves can cut through the murky layers of the Milky Way, revealing galaxies that lie behind our own stars. This capability opens up a whole new perspective on the universe, allowing us to see what was once hidden from view. Radio telescopes also play a vital role in this cosmic investigation. The Parkes telescope in Australia, for example, is famous for picking up faint signals from neutral hydrogen in distant galaxies. These signals can slice right through the galactic disk, providing valuable information about the structure and movement of galaxies that are otherwise obscured. By combining data from these different types of telescopes, astronomers are starting to piece together a more complete map of the hidden universe. However, the Great Attractor remains partly shrouded in mystery. Even the James Webb Space Telescope, our most advanced instrument to date, struggles to fully penetrate the thickest clouds of cosmic dust. This ongoing quest to understand the Great Attractor not only challenges our technological limits, but also pushes the boundaries of our knowledge about the universe. Each discovery brings us closer to unraveling the secrets of this gravitational anomaly, revealing the intricate web of galaxies that lie beyond our immediate view. The universe is vast and full of surprises, and with every observation, we inch closer to understanding the grand tapestry of cosmic structures that shape our reality.
When we gaze into the cosmos, we often think about the stars and galaxies that light up our night sky. But what if I told you that most of the universe is made up of something completely invisible? Enter dark matter and dark energy, two of the most intriguing mysteries in modern astrophysics. Let's start with dark matter. It's estimated that about 85% of the matter in the universe is dark matter. That's right, 85%. Yet, we can't see it, touch it, or even detect it directly. So how do we know it's there? The answer lies in its gravitational influence. Dark matter doesn't emit light or energy, but its presence can be inferred by observing how galaxies and galaxy clusters behave. They move in ways that suggest there's more mass present than what we can see. Take the Great Attractor, for instance. This massive gravitational anomaly is located in the direction of the Centaurus constellation. It's not just a collection of visible galaxies, it's surrounded by a vast concentration of dark matter. This invisible mass is likely what's pulling galaxies toward the Great Attractor, creating a cosmic dance that we're only beginning to understand. Now, let's shift gears and talk about dark energy. While dark matter pulls galaxies together, dark energy does the opposite. It's a mysterious force that's driving the accelerated expansion of the universe. Imagine a balloon being blown up. The more air you add, the faster it expands. That's similar to what's happening on a cosmic scale. Dark energy is pushing galaxies apart, counteracting the gravitational pull of dark matter and normal matter. This interplay between attraction and expansion is at the heart of the universe's most fundamental conflict. The Great Attractor is like a cosmic battleground where these forces collide. On one side, you have gravity, pulling everything inward, and on the other, dark energy, pushing everything outward. It's a delicate balance, and understanding it could unlock the secrets of the universe. Scientists are still piecing together the puzzle of dark matter and dark energy. They're using advanced telescopes and particle detectors, probing the very fabric of space and time. Each discovery brings us closer to understanding not just what these forces are, but how they shape our universe. So, the next time you look up at the stars, remember that there's so much more happening beyond what meets the eye. The universe is a complex tapestry woven from visible and invisible threads, and we're just beginning to unravel its mysteries. The Great Attractor stands as a testament to the wonders of the cosmos, reminding us that even in the vast emptiness of space, there are forces at play that challenge our understanding and ignite our curiosity.
Imagine standing under a night sky filled with stars, each one a distant sun, each constellation a story waiting to be told. But what if I told you that this familiar canvas is not as permanent as it seems? In about 4 billion years, our Milky Way galaxy is set to collide with our neighboring galaxy, Andromeda. This monumental event will reshape our cosmic neighborhood, creating a new galaxy that some have whimsically dubbed Milk-Dromeda. Picture this: two massive spirals swirling together, their stars and gas intertwining in a cosmic dance. The gravitational forces at play will be immense, pulling stars from both galaxies into new orbits and giving birth to new stars in the process. Over time, the night sky will transform dramatically. The constellations we know today will fade into obscurity, replaced by entirely new patterns of light. But the story doesn't end there. As Milk Dromeda continues its journey through the universe, it will not be alone. Our entire local group of galaxies, including the Triangulum and several smaller companions, will be drawn deeper into the gravitational embrace of the Great Attractor, a mysterious region of space that exerts an enormous pull on galaxies. Fast forward billions of years, and we find ourselves in the Shapley supercluster, a colossal assembly of galaxies that will redefine our cosmic landscape. Imagine gazing up at a sky filled with unfamiliar stars, where the constellations we once recognized have been replaced by new formations, telling a different story of the universe. This cosmic evolution is not just a distant event, it's a reminder of our place in the universe. Each star we see is a part of a grand tapestry woven together by the forces of gravity and time. As we look up, we are witnessing the slow, majestic unfolding of cosmic history. So, what does this mean for us? It means that we are part of a dynamic universe, one that is constantly changing and evolving. Our understanding of the cosmos is still in its infancy, and as we continue to explore, we uncover the mysteries of our existence. The night sky is not just a backdrop, it's a living, breathing entity, and we are all part of its story. In the grand scheme of things, our lives are but a fleeting moment in the vast timeline of the universe. Yet, it's in this fleeting moment that we find our purpose, our curiosity, and our desire to understand the cosmos. So, as we gaze up at the stars, let's remember that we are not just observers. We are participants in this incredible journey through space and time.